Now, this problem is going to be really inconvenient as far as StatCrunch is concerned, because it does not give us a way to load these points into StatCrunch. The only way we can do this with StatCrunch, which is by far the better way to do it than trying to use these formulas, which are extremely complex, is to go ahead and actually determine what the coordinates of all of these points are and physically type them into StatCrunch. I could go ahead and use this same screen that I've got right here and just delete all of this data. Or I could open a new StatCrunch. If I take a look at this, now this, I can make it bigger, or I can just go ahead and hit this, which will pull it out, although it doesn't give me a whole lot of the values here. I've got 10, I've got 10. This is counting by ones. So I'm going to put these points down here in first, because in a minute it's going to ask me to delete this point and see how that affects things. This is obviously what we would call an outlier. So these points are, this lines up with 10, 9, 8. Down here, this lines up with 10, 9, 8. So I could just put these in backwards. I've got 3 points where the X value is 10. The corresponding Y values are 10, 9, and 8. And then I've got 3 points where the X value is 9. And my Y values are 10, 9, and 8. And then I've got 3 X values where that are 8. If you see where I'm getting this, I don't want to run off and leave you here. This lines up with the 8, the 9, and the 10. These likewise line up with the 8, and the 9, and the 10. So this is the point 8, 8. This is the point 9, 8. This is the point 10, 8. And then this would be the point 8, 9, or sorry, yes, 8, 9, 9, 9, 10, 9, and so on over to 10, 10. So I'm just putting these values in over here. So 10, 9, 8. And then this point, this is the point 2, 2. So now let me get rid of that. Let me clear all my doodles out. So with all 10 of these points, these data do appear to have a strong correlation. I could easily see that drawing a line through here would actually include 4 of the 6, and then it would definitely minimize the distance between these other two. These other, well, 3 above and 3 below. So I would definitely, looking at all of these, say, yes, we have a good linear correlation going here. What did they say? Okay. What is the value of the correlation coefficient for all 10 data points? Let's just go ahead and do it with the summary stats. Let's do it with the summary stats. So we'll go stat, summary stats, correlation. Highlight the values. We want a two-sided p-value, two-tailed. Compute. So our correlation coefficient is a pretty strong looking 0.880. So is there a linear correlation between X and Y? Use alpha equals 0.05. The probability of getting this value is 0.0008. Much, much smaller than 0.05. So because it would be in the critical region. Now they're asking, what is the correlation coefficient when the 0.22 is excluded? So I wonder if it'll just work if I take these 2 points out. I want to delete that. Delete that. Let me just run it again. Oh, now the correlation is 0 with the probability of getting that at 100%, a 1. So the correlation, remember your R value, the closer it is to a positive 1, R is always going to be between -1 and +1. The closer it is to 1, that means the points lie in a straight, perfect line that's going up. At -1, you've got a straight, perfect line going down. At 0, there is no correlation, which means they're just all over the place. So if we only had these points, how would you know where to draw a correlation line? You could draw it like this, or this, or this, or this, and it would all be just as valid. So there's basically no correlation going on here. So now the correlation coefficient, when we take the 0.22 out, is actually 0. Outliers have a strong tendency to affect the correlation values. Often they'll just take it off to one side or the other, but this one actually created one where there was none. So now, is there a correlation between X and Y? No, because the correlation is 0. It's not in the critical regions, out in the tails. So what do you conclude about the possible effect from a single pair of values? Definitely it can change the conclusion. Now try these yourself, only keeping in your notes how to use the StatCrunch. With StatCrunch, we're typically going to do summary stats, correlation, highlight the columns, and if it's a two-tailed value, click on two-sided, and then hit compute. Or you might be using stat, regression, simple linear. Again, you highlight the columns. This is where you can also enter a hypothesis test. This hypothesis test is a hypothesis based on the intercept being 0 and the slope being 0. Or you can do a confidence interval here. You can use this to predict a Y value based on a given X value. So once you get the correlation equation, you can use this to enter a particular X and see what the Y value would be based on the equation. And this is where you can also get your your scatter plot. All kinds of great things we can put in here.